Unit 1, Day 4, Z-score. Objectives. I will be able to, given data, collect and interpret Z-scores for a dataset. I will be able to, given a Z-score, calculate a data point. Let's take a look at situation number 1. The average car weighs 4,000 pounds with a standard deviation of 700 pounds. My car weighs 5,600 pounds. The average truck weighs 6,000 pounds with a standard deviation of 1,200 pounds. My brother's truck weighs 7,800 pounds. Which vehicle is heavier? Well, because 7,800 is greater than 5,600, the truck will be heavier. Which is heaviest in its own group? That means relative to the average weight of the car or truck. For that, we need to use z-scores. Let's take a look at some vocabulary before we get there. A measure of dispersion tells you how the data is spread out. We've used some measures of dispersion such as range, interquartile range, and standard deviation. Remember that standard deviation tells you how spread out a data set is from the mean. Now we're going to be able to use z-score, which is like a shortcut method that tells you how many standard deviations a single observation is from the mean. Let's take a look at this example to help it make more sense. Consider the following sample. That means just some. From a population, that means all, with a standard deviation equal to 2. Remember, that means standard deviation, and mean equal to 30. So notice this is just some of the observations. It is not the entire data set. See in the observations how there is a point that is at 30, and they said that the mean is 30, and that the z-score is 0 for that observation. Because a z-score tells you how far away the observation is from the mean, when the z-score is 0, then that data point, that observation, is the mean. When the z-score is positive, like positive 0.5, positive 2.5, positive, positive, notice that all of these values are above 30. These are all positive z-scores, therefore the observations are above the mean. Remember that 0 means that observation is the mean, so positive will be above the mean. When you see negative z-scores, you will have numbers in this sample less than the mean, which is 30, so less than 30. A negative z-score indicates that the observation is below the mean. Let's mark the mean and standard deviations and chart the observations on the number line. So beginning with the mean, that is 30, we'll put that as mu. Also remember that's x bar. And now the standard deviations. So the standard deviations that are above the mean are 2 units above the mean. So if the mean was 30 and I add 2, I get 32. So here is one standard deviation above the mean. 32 plus 2 makes 34. So here is 2 standard deviations above the mean. Then to go below the mean, we subtract. The mean minus 2 makes 28. 28 is -1 standard deviation because the standard deviation is 2. Let's subtract it again. 28 minus 2 makes 26. 26 is -2 standard deviations from the mean. And then we can plot the observations or chart the observations on this number line. 31. 31 is right here. Notice that's a positive z-score, therefore it's above the mean. Notice that the z-score says 0.5, which means this is half of a standard deviation above the mean. So half of the standard deviation of 2 gives us 1. So we are 1 unit above the mean, or instead of 30, 31. 29 is negative 0.5, so that's going to be below the mean. Where's 29? Here it is, below the mean. 35, notice where 35 is. That's in the zone that is unusual because it's greater than 2 standard deviations from the mean. Notice that the z-score for 35 is more than 2. That's an indication quickly to tell us this is an unusual data point. Let's continue charting more observations. 33.5, 37, another unusual data point, 30, right on the mean because the z-score is 0, 26, and 28.25. Here is the z-score formula for when you need to calculate the z-score given information. The z is for the z-score. The x is for the observation or the data value. The mu is for the mean, and the sigma is for the standard deviation. Let's look at some examples. On a certain test, the class average was 76 points. Average is the same as mean, so the mean is 76 for this problem, with a standard deviation of 3. Calculate Kelly's z-score, so that's what we don't know. Z is the question. If her test score was 83, that's the observation, so that's x. X equals 83. So using this formula, first we put z. We don't know z, so we write z equals, then we put x. X says 83 minus, then we put the mean. We wrote the mean as 76 divided by, then we put the standard deviation, which we said was 3. That equals 2.3. So that is Kelly's z-score. Is her score unusual? Explain. So remember that more than 2 standard deviations is an unusual observation. So yes, because her score is more than 2 standard deviations from the mean. See how easy it is to use a z-score to tell us where a data point lies? This is above the mean and more than 2 away from the mean, so it's unusual. Part B. If Kia had a z-score of 1.5, so now z equals 1.5, what was her test score? Now we don't know the observation. So again, let's use the z-score formula. This time we know z. Z is 1.5 equals, but we don't know x, the observation. X minus, this is the same problem where the mean is still 76 and the standard deviation is still 3. How do we get this x? We have to undo this equation or solve for x. So remember, the last thing we would do here is divide by 3. So to make the divide by 3 go away, we multiply both sides by 3, since multiplying is the inverse of dividing. That gets rid of our 3, and we end up with 4.5, because 3 times 1.5 makes 4.5, equal x minus 76. What's the inverse of minus 76? Add 76. When we add 76, we get that x equals 80.5. So Kia's score is that x value, 80.5. Using the z-score. A z-score is the number we can use to compare things that are not alike. Let's take a look at situation number 2. An average ant can run 196 inches per minute. So the average for the ant is 196. The mean is 196, with a standard deviation of 12 inches. Auntie the ant can run 220 inches in a minute. So that's one observation from one ant. An average man can run 322 meters per minute. So there's another mean, but for a man, with a standard deviation of 147 meters per minute. Billy, a very fast high school student, can run 510 meters per minute. Here is an observation for the humans and not the ants. Who is faster? Well, of course Billy is faster because Billy's a man, not an ant, and because 510 meters is greater than 220 inches, of course. But who is relatively faster, faster in his own group? For that, we need to calculate the z-scores. So let's start with Auntie's z-score. Remember the z-score formula. We start with the data value minus the mean and divide by the standard deviation. So her z-score is 2. Now let's calculate Billy's z-score. We start with the data value, subtract the mean, and divide by the standard deviation. His z-score is about, approximately, almost 1.3. So who's relatively faster? Well, this is a z-score that's more above the mean than 1.3. Therefore, Auntie is relatively faster because 2 is farther from the mean. So she may not be faster than Billy, but she is faster compared to most of the ants than Billy is compared to most of the humans. Situation number 3. The mean price of a CD is $10, so mu equals 10, with a standard deviation of $2. The mean price of an iPod is $220, with a standard deviation of $20. Someone offers to sell you a CD for $8 and an iPod for $190. Which is the better deal? Why? So again, let's find the z-scores. For the CD, the z-score is the observation from the CD minus the mean from the CD divided by the standard deviation from the CDs, and that makes -1. For the iPod, the z-score is the observation minus the mean of the iPod divided by the standard deviation of the iPod. And that makes a z-score of -1.5. So which is the better deal? Well, we want to pay less money, and this number is more negative, so it's less money because it's more below the mean. Therefore, the iPod is the better deal because it's farther below the mean than the CD, or rather, it's relatively less expensive. B, to make the other deal as good as your choice in Part A, what would have to be the selling price of the other item? So we want the CD to have the same z-score as the iPod. So let's make the z-score negative 1.5, the data point unknown, but we're still using the same mean and the same standard deviation that we're given. And we solve for the observation x. Multiply both sides by 2 to get rid of that divided by 2, and we end up with negative 3 equals x minus 10. Add 10 to both sides, and we end up with x being 7. That means the CD should cost $7 if we're going to make it as good of a deal. Take a moment to write a short summary. Explain a situation in which knowing a z-score would be useful. See you in class.